Okay, in this video, we are going to discuss the naming of molecular compounds, specifically only one type of molecular compound, and that's going to be what's called binary molecular compounds. All the information you need to know about naming binary molecular compounds can be found on this particular sheet. Now, what is a binary molecular compound? Well, water is a binary molecular compound. Good old H2O. And what a binary molecular compound is a compound comprised of molecules like water is. And it's specifically a molecular compound that's comprised of two elements. So this has hydrogen and oxygen. The bi is like bicycle, two wheels in a bicycle, two elements in a binary molecular compound. Now, one thing we need to recognize when naming binary molecular compounds is that there's a completely different naming system for binary molecular compounds than there is for ionic compounds. And when you come across a compound, you're not always going to know which is which. Well, how do you tell the difference? Well, here's the way you do it. If you want to name an ionic compound, you should recognize that the ionic compound contains ions. So ionic compounds contain ions. Well, how do you know if it contains an ion or not? For this class, and this is going to work 95% of the time, you have ions in a compound if the compound contains a metal or the ammonium ion. If you see either of these two things, a metal or the ammonium ion in the compound, it's ionic. You're going to use the ionic naming system that we covered in the last two videos. If it doesn't contain a metal or ammonium, then we're going to use the binary molecular compound naming system. And here's the way it works. It's really, this is a lot easier, in my opinion, than naming ionic compounds or writing formulas for ionic compounds. For example, let's say we were going to name this compound here, which we all know is carbon dioxide, CO2. Well, let's go through the process of naming this particular binary molecular compound. Well, what we first do is we write a prefix that shows the number of the first atom. So I look at my first atom, and I see it's carbon, and there's only one of them. And in my list, the prefix I should use is mono. However, if we look here in our rule, the rules that we have for naming binary molecular compounds, we see that we use this prefix at the beginning except for mono. So that's why I've got mono written here, and it's crossed out. But I do write, the next step is to name the first atom, which of course is carbon. Then we move on. We write the prefix showing the number of the second atom, which is 2. So I write di. Here's your di. And then you move on to the last step. You name the second atom with an IDE ending. Oxygen goes to oxide. So this is how we name this binary molecular compound. We follow these 4 steps, and we would end up calling it carbon dioxide. And that's pretty much it. And so using this system, when you see a molecular compound, what is a molecular compound? It doesn't contain a metal. It doesn't contain the ammonium ion. Then we're going to use this system here to name the compounds. And we're just going to try a couple, okay? We're first going to start with this molecule, which has a carbon atom and an oxygen atom. And when I see this, I ask myself, well, is this ionic or is it a molecular compound? There's no metals, there's no ammonium. Carbon's a nonmetal, oxygen's a nonmetal. As a reminder, the way you tell the difference between metals and nonmetals, remember, it's losers to the left and receivers to the right. Losers to the left of the periodic table and receivers to the right of the periodic table. So once again, let's look at it here. There's a little stair step that runs down the periodic table like this. Anything on this side of the stair step, which carbon and oxygen are, is going to be a nonmetal. Anything on this side of the stair step and all this stuff down here, those are our metals. And so carbon monoxide contains no metals, no ammonium. We're going to use the binary molecular compound method for naming this. So I use my prefix showing the number of the first atom, which is mono, but we don't write mono for the first atom. Then I write the name of the first atom, which is going to be carbon. Then I use the prefix showing the number of the second atom, which is mono in this case. And we do write mono if it's the second atom. So I'm going to write mono. And then I write the name of the second atom with an IDE ending. The second atom is oxygen, so we're going to instead call it oxide. Now, in this case, you might say the name is carbon monoxide, but what we really do is if there's like two O's like this together, we drop one of them. And so instead of calling this compound carbon monoxide, we just call it carbon monoxide. It just rolls off the tongue a little bit better. So that's how we name this one. Let's try another one. Let's try another particular compound. The next one we are going to name is PCl3. This is phosphorus. I'm not going to call it monophosphorus. I'm just going to call it phosphorus because we dropped the mono. Prefix showing the number of the second atom. Let's see, 3. We're going to call that tri. Name of the second atom with an ID ending, that's going to be chloride. So we would call this phosphorus trichloride. Let's do a few more here. We're going to try N2O5. How are we going to name that one? Well, what's the prefix showing the number of the first atom? It's going to be 2 for di. It's going to be di what? Dinitrogen. Looks like 5 oxygens. What's the prefix for 5? Penta, like pentagon. Pentaoxide. And what we do when we have 2 vowels together like this, we're going to drop this here because dinitrogen pentoxide rolls off the tongue a little better than dinitrogen pentaoxide. All right, 2 more here. N2O4 and NCl3. Dinitrogen tetroxide. 4, the prefix for 4 is tetra. Like Tetris. In Tetris you got shapes with 4 squares falling down. That's kind of how I remember this prefix. So this is going to be dinitrogen tetroxide. And this is going to be nitrogen. We dropped the mono. It's not mononitrogen. It's just nitrogen. Oh, I forgot. Trichloride. So that's going from formula to name. Let's do it in the opposite direction. We're going to do a couple from name to formula. Okay, let's try this one. Sulfur, hexa, well, that sounds like hexagon, doesn't it? Fluoride. Yeah, sure enough, hexa is the prefix for 6. So this is just going to be SF6. You can see it here. And our list of prefixes, indeed, 6 is hexa. Dinitrogen, that's going to be N2, right? Dinitrogen trioxide. Well, that's going to be N2 O3. Pretty straightforward, I think. Let's try this one. Dihydrogen monoxide. Let's see, that's going to have two hydrogens, H2, and a single oxygen. That's going to be H2O. Well, I guess if we were getting technical, we'd have to call water dihydrogen monoxide, but we'll just keep calling it water. That happens a lot with a lot of chemical compounds. They have common names that everyone knows, and we just use that particular name. But if you were to tell me that you were doing some experiments with dihydrogen monoxide, I'd know exactly what you were talking about. All right, one more. Sulfur trioxide. Well, that's going to have a single sulfur, and we're going to have three oxygens. So that's going to be SO3. So the key here, folks, when you're naming all of these different compounds, ionic or binary molecular, you have to remember that there are two different systems for naming these. So if you see a particular compound, let's see like NH4, ClO3 minus. If I see this thing, if I don't have my polyatomic ions memorized, I'm going to miss that that's the ammonium ion there. And of course, I know this is the chlorate ion. And so I would call this ammonium chlorate because in the ionic system, you name the cation and then you name the anion. So you need to go through a lot of practice naming ionic compounds and naming binary molecular compounds in order to be able to keep all this straight.